Okay, so what I need to ask you is, do you remember what a ratio is?
Yes.
What's a ratio? Katie, whoever can tell me a definition for a ratio. Okay, Dana, go for it.
A comparison of...
You are cheating. You are cheating. You don't get to do that, you cheater face.
Comparison of number in relation to numbers.
It's a comparison of two numbers. How is it usually written? Yeah?
Number...
That's actually the least common way.
fraction.
It's usually written as a fraction. So it's a comparison of quantities You know what quantities are, right?
Yes.
Like numbers, amounts. And it's represented as a fraction. Can it be represented as a decimal?
Yes.
Yeah, you can represent fractions as decimals. 1/2 is 0.5. But some fractions, when you turn them into decimals, turn into really ugly decimals, don't they? Like 1/7 goes on forever. It's kind of ugly. And so we're going to try and stick to fractions as much as we can. And what's the rule about fractions? What do we always do to fractions? We always simplify our fractions. Okay? So we're going to have that. Now, a trigonometric ratio is a ratio, which means it can be written as a fraction. It can be written as a fraction. What do you think trig tells us? Tri, 3, so those are triangles. Metric? Measure. So we're measuring triangles. That's all we're doing with trig, is measuring triangles. And I just call it trig because I'm lazy, and most mathematicians are. And so a trig ratio is a ratio of the lengths of two sides of a right triangle. So it's a ratio of the lengths of two sides of a right triangle. And it has to be a right triangle. Remember how we just came off doing our special right triangles and all that stuff? For trig, we're doing right triangles. So if you don't have a right triangle, you're not doing trig for now. When you get into the fancy trig stuff in your pre-cal class, then you'll get to do other things. But for now, we're sticking with right triangles. Okay? You're like, okay. Now, it gets used for stuff. Okay? Okay? So, we can use it to find missing side lengths. Missing side lengths in what? In a right triangle. Are you going to use this to find missing side lengths in a circle?
No.
No. Okay. And it only works with acute angles. Okay. So whenever we're talking about setting up a trigonometric ratio, you can only ever do it if you have an acute angle. You never use trig on a right angle for our class. Okay? That's going to get way too complicated and hairy and disgusting. You don't want to mess with it. Okay? And again, it only works with what shape?
Right triangle.
On right triangles. What shape does trig work on again?
Right triangle.
And then what shape does trig work on?
Right triangle.
Are we sure?
Yes.
Have I driven that point home obnoxiously enough?
Yes.
No, I need to be more obnoxious? Okay. I can be more obnoxious. And now you get to learn Greek. A bunch of you already know some Greek letters. What are some Greek letters y'all know?
Alpha.
Alpha, pi, beta,
Kappa.
kappa,
Omega.
omega, that last one with the little feet on it.
Theta.
And now you get to learn theta. Theta is just this little oval with a line through it. And it always represents our acute angles in our right triangle. So it's the symbol for our acute, what we call reference angles. So it's just a symbol for your acute reference angles. So is a right angle ever going to get to be theta for us?
No.
That's a big fat no, because theta only goes with acute angles, and a right angle is not acute. It's right. And I know that blows your mind, but just stay calm. It will be okay. You okay? Okay. Don't want anybody exploding or anything. So you look at this triangle, and I want you to label angle A as our reference angle. What will you label it with so I know it's our reference angle? A theta. So you'll come in here and go, there, now angle A is my reference angle. That's the one I'm referring to. And theta describes the degrees of that angle. Okay, it's describing the number. A is the name of the angle. Theta is talking about the angle itself and how big it is. Okay? And then, once you know what angle you're focused on, then you label everything else. What is the name of the side across from the right angle always? It's always the hypotenuse. Always. I always label that one first, so I don't accidentally call something else the hypotenuse, and I don't accidentally call the hypotenuse something it shouldn't be. Okay? So you just get used to that. And then you think, okay, which side is opposite of theta? Little a, little b, or little c? Which one is opposite of theta? Well, if you go across, little a, so this is your opposite side. Okay? It's always across from theta. And the hypotenuse was always what? Across from the right angle? Okay? And so then you have this one, the side over here, side B. It comes up here and touches theta. What should we call the side that touches theta?
Adjacent.
It's called the adjacent angle. What's adjacent mean? When we did adjacent angles, what does adjacent mean?
Next to.
Next to. The adjacent side is the leg next to theta. Does the hypotenuse get called adjacent? No. The hypotenuse always gets called the hypotenuse. Even though the hypotenuse is technically adjacent to theta, it never, ever, ever, ever gets called adjacent, because it's the hypotenuse. It's special. I know, you're very impressed. So now over here on, what kind of triangle do I have here? A right triangle. Let's make angle B the reference angle in this one. So will you label angle B as your reference angle? What do you label it with? Theta. Let's go ahead and say, okay, that guy's theta.
Wait, how do you know that?
Because I just told you. Let's call angle B our reference angle. Okay. So I now know angle B is my reference angle. I want you to label the hypotenuse, the side opposite, and the side adjacent. Go. I always do hypotenuse first so I don't make mistakes, but that's up to you. Because the hypotenuse is always across from the right angle, and that's just easy to find. Okay, now you look to see if yours match mine. Now, what do you notice about these two pictures? They're the exact same triangle, aren't they? They're the same ding-dang triangle. And look, is the hypotenuse always in the same place? Yes, the hypotenuse is always the hypotenuse. But depending on which angle you're referencing, which angle you're referring to, if you're referring to angle A, this side is the opposite. If you're referring to angle B, this side is opposite. So do you kind of have to pay attention to where everything is? Yes. Yeah. Would it be helpful if you marked it on there? Okay. Now, because we're lazy, Do you want to write hypotenuse and adjacent and opposite out every single time you have to mark a triangle? Of course not, because you're lazy. So if you're going to label opposite, I usually just do OPP. Or you can even just use the big letter O, so that you know this is the opposite side. Ooh, ah. What do you think we should do for adjacent? ADJ? And the English people think that's an adjective, but not here. That's adjacent. Or you could just use the letter A. I don't tend to do that because a lot of your triangles will have A already be a letter in it. And I don't want to confuse what I'm doing. And so I'll usually just write ADJ so I don't mix it up. What do you think we should put for hypotenuse? Height? You can put hypo if you want, but I'm just going to put height because I'm especially lazy. Or you could use an H. I don't care. Okay? And then you go, now wait a minute. There's other things that are being talked about here. This is your 3 new trig words. Now there's a lot more trig words than this. These are just the most famous 3. But there's 3 other ones, and then there's all their hyperbolic versions and stuff, and see, Jane's so excited by it. I mean, look at that. That's just overly excited. You just should calm down, really. Okay? And so a tangent is one of our trig ratios, but it gets abbreviated too because we're lazy. Guess what we usually abbreviate it to? Tan. And that is the best tan you can get because I'm telling you, no skin cancer from this tan. Okay? And yes, I am that person who puts that kind of math joke on my Facebook and on my Instagram. Absolutely. Okay? What do you think? Oh, how do you say this guy?
Sine.
Sine. And guess how you abbreviate it?
Sin.
But do we ever say it's sin? No, the math gods do not want you sinning. No sinning in here. You see this thing and you still say sine. Just like you see tangent and you say tan, you know. Say it the way it's supposed to be said. That's still sine. No sinning allowed. Okay? I'm sorry. I know that you were excited to sin all the time, but you must say sine. So how do you say this last guy?
Cosine.
Cosine. How are we going to abbreviate that one?
Cos.
Cos or cos? It's just cosine. Okay. And they're the most famous ones. There they are, right in the center of your calculator. Sine, cosine, and tangent. Now you get to use these buttons you've been looking at all this time. Now you get to use them. Are you excited?
I get weird things on a graph when I
So excited. No, we're not going to even go that far. We're not going to even go so far as to graph them. That's pre-cal. You don't get to do that in here. So, candy to the person who can read this out loud properly. What does this say? Oh, lots of victims trying. Okay, Marcus?
Sine theta equals
Sine theta equals. Okay, go get it. What is theta?
referencing.
It's an angle, so the sine of some angle equals. Do you know what sine does? No, but that's how you read it. Okay? Let me tell you what it is. When you sine an angle, you are finding the ratio of the lengths of 2 sides around that angle theta. And for the sine, it's always going to be the ratio of the opposite side over the hypotenuse. No matter how big your triangle is. If you've got whatever number here, this ratio will always be the same every time. It could be if it's a 30, 60, 90 triangle, it could be a 30, 60, 90 triangle that's this big, or it could be the size of the universe. But this ratio of the side opposite compared to the hypotenuse will always be the same amount. Ooh. Ah. Okay? I need somebody else who would like to attempt to read what this feller says. I don't do voluntold. Yes.
Cosine theta equals.
Cosine of theta equals. You want to know what the cosine of theta equals? Too bad, you have to find out anyway.
Hypotenuse hills.
No, I think it should be, but it's not. It's actually the ratio of the adjacent side over the hypotenuse. Will these two numbers ever be the same? Will these two ratios ever be equal? Yeah, if your opposite equals your adjacent, will you end up with the same ratio for these? Yeah. If you have an isosceles triangle, they come out the same. Kind of a fun thing to figure out. And then you got this guy, last person for candy. Didn't you just get it?
I didn't.
Oh, okay, go get it. Okay, yes.
Tangent of theta equals.
The tangent of theta equals. And so the tangent of theta gets rid of the hypotenuse. Now it's your opposite side over your adjacent side.
What if they're the same? Then it's just
Then it would be 1. And yes, you can get a tangent equal to 1. So yeah, if you had an isosceles triangle here, then the opposite and adjacent would be the same, and what would your tangent of your angle be?
1.
1. Well, guess what angle would you have in an isosceles right triangle? How big are your angles in an isosceles right triangle? 45, 45, 90. Remember that one? And so if you ever get a 1 for your tangent, you know you've got theta being 45 degrees. There are people who figured that out. They actually made tables of all these numbers. They figured out, what if I have a 1 degree angle? What if I have a 2 degree angle? What if I have a 3 degree angle? And they figured out these ratios for every angle. And they would have these huge tables. And they would have to write them down and make them up and look them up and stuff. And then somebody said, well, what if I just program it into this lovely little device? And then you don't have to look it up anymore. And so that's what you do. How are you going to remember which one is opposite over hypotenuse, which one is adjacent over hypotenuse, and which one is opposite over adjacent?
So, where's the one?
Oh, you even read it right. You SOHCAHTOA. So if your brain is hurting from this, SOHCAHTOA. Okay? Okay. Shh. Yeah. But look, how does this help you remember? Well, what does the S remind you of? No sinning. And what two things go into my sign? The opposite over the hypotenuse. And what's the C for?
cosine.
Cosine. And what two things go into that ratio? Adjacent is over hypotenuse. And then the T is for tangent, which will be your opposite over your adjacent. So if you can just remember SOHCAHTOA, you'll be able to remember which thing goes with sine, which thing goes with cosine, and I still use this sometimes because my brain just sometimes doesn't think, and so I have to go back and remember S-O-H, opposite and hypotenuse. There it is. Okay? TOA is often people's favorite. They just like the TOA. Somebody else was saying, what's the name of the shiny crab dude in Moana?
Tamatoa.
Tamatoa. Somebody said this is his boring brother. This is Tamatoa's little brother, who's kind of boring and sits in the corner doing math. Not shiny at all. Okay? I don't care how you remember it. You remember it your way. Okay? Now, if you did... What you need to do is you need to go get a calculator. Because I'm going to teach you how to use the magical buttons on the calculator. Get your own.
3, actually. What?
If you have your own emotional support calculator, you can get it out. Now, pop quiz. How big is a degree in math?
180.
What do you mean? Like,
How big is a degree?
It's this big, because that's the degree set.
it's pretty big.
It's
I would say it's,
1/360th of a triangle? No,
Yes.
of a circle.
yes.
You're like, what? If you take a circle and cut it into 360 little pieces with slices, it would be one out of that. So are they fat or thin?
They're thin.
They're really thin, because 360 of them will fit in a circle. But they're not the only thing we measure circles with. Okay? So Joe, circle. What's this red thing? A radius. If I took that length and cut it out of red string and draped it around the side of my circle there, and then I said, this size wedge, right there, that size angle, that's the size of piece I want to cut my circle into, not degrees. Does this look bigger or smaller than a single degree? Much bigger. This is a whole lot bigger than a single degree. This size of pizza slice is called a radian.
Which one?
The size of this angle. Do you think you can fit 360 of these inside the circle?
No.
That would be no. In fact, you can fit exactly 2 pi of them. So it's 6.28 of them will fit in a circle. And you're like, why the heck would we ever do that? Don't worry, you'll get to that in pre-cal. Okay? But, the reason why I'm telling you about it is because your calculator, press up here on your calculator, press the button that says mode. And go down and see on like the third or fourth line, there's radians and degrees. And if radians is flashing, you don't want that. You want degrees to be selected. Did you hit mode?
Yeah.
And it's down like on the fourth line? Okay. You want it to always be on degrees. So if yours is not selected for degrees, you'll always want to make sure you arrow over to it and hit enter to select it so that degrees is the one that's highlighted in black. Okay? Because you don't want to use pieces this size. That's going to give you goofy answers. You don't want radian size pieces. You want degree size pieces. And so, guys, this is massively important. Because if you don't check this every time you turn on your calculator to do your math and make sure it's sticking in degrees, you might get to the test, accidentally have it in radian mode, and all your answers will be wrong. So you need to always make sure your calculator is in degree mode. That's what it says right here. It wants to be in degree mode. Okay, because we are using degrees. We're not going to use radians in here. You don't want them. They're strange. They don't fit neatly in a circle. And so we're not using them. We're going to use degrees, but you have to always make sure your calculator is in that mode. Once you set it in that mode, it'll usually stay that mode for like a day or two. But like if you leave it overnight, you might have to check it the next day to see if it's gone back because it defaults to radians. Because it's a scientific calculator and scientists actually use radians more. So, yeah, the evil looks I'm getting. This is not my fault, okay? Would you just not look at me like that? Golly. I'm telling you to stay in degrees, and that's it. Now, do you know how to get out of this menu?
Second,
No, clear won't do it.
second mode.
Second quit.
She just got it.
You can sometimes hit clear, sometimes you have to second quit.
What?
It gets stuck sometimes. If it gets stuck, you have to quit.
How does it get started?
It just doesn't want to clear for some
I
reason.
just tried to follow.
Okay. Shh. Okay. So now let's practice. Now that your calculator is in the proper mode, will you type in these things? Now notice, look what I have written here. What's this squiggly thing? Is that just hot air?
That's about.
The approximately equal? Shh. The reason why I have approximately equal is because this is supposed to be a ratio, but it's going to be an ugly ratio, and your calculator is going to give it to you as a decimal. Okay? And since it's got to round off that decimal, your answer is only approximate. So if you ever do a decimal with these guys, you're always going to have the approximate symbol. And let's go with 3 decimal places today. So if you will, just practice typing these into your calculator to see what you get. I'll give you a minute.
What are we rounding to here?
Let's go with 3. 3 decimal places.
3 decimal places?
Let's see here. I'm going to press the sign button, and then 35, and then, how do you make it equal? Hit enter. Did y'all get 0.574? Do you have to put the 0?
No.
Actually, no. You could leave that off. Okay. What units do you put? None. No units. Because it's a ratio of 2 of the same thing, and so the units cancel out. There are no units on trig. Yes. I know, you're very excited. Okay. Cosine. Somebody tell me how you did cosine. Tell me what you typed.
Cos.
Yes? Cosine. Don't tell me cos. Cosine what?
And then I put the period,
Uh-huh.
and then I put the parentheses.
Notice, did I put the parentheses at the end of mine? No. Did it still work? You can get a little bit lazy if you're just putting numbers into your cosine or your tangent or your sine. You can leave it off and it just goes, okay, yeah, you're done. So, just save yourself a keystroke if you want. And you got 0.743? Yes?
35 and 26, 61.
I'm sorry, I can't hear you.
35 and 22 and 61 is a degree.
Yes, these are all going to be degrees. Because remember, theta is an angle. And so this is the measure of that angle. So the sine of a 35-degree angle is this.
Why doesn't it have a degree?
Because it's just talking about signing the number. You could put degrees. But yeah, it's not going to usually. Because we assume that you know it's an angle. And also because sometimes you're talking about radians. And so we just put the number. Okay? And then the tangent of 61, somebody who found that one? Yes?
1.804.
1.804. Okay? What should you not get? Negatives. Guess what you did if you got a negative? You didn't change it to degrees. So if you ever get a negative on here, go back and check your mode and make sure you put it in degrees. Okay? Because those will not happen with degrees. Okay? All right. Now we're ready to see what we can use this for. Turn the page. Shh. So, oh darn. First you have to practice writing trig ratios before you can use them to do stuff. I totally just bamboozled you there. Okay? So you're going to find the following trig ratios. So here, it's telling you to find the sine of r. What is r? It's one of my angles. So this is the reference angle. It says to find the sine of r, so that's the one you're using as theta. That's the angle you're referring to. Well, how do you find the sine of something again? Well, that's your reminder, but how do you find the sine? Sine is what? Opposite over hypotenuse. So the sine of angle r is going to be the length of the side opposite over the length of the hypotenuse. Well, how big is the opposite side? 12. See? Straight across. Opposite. And then the hypotenuse is 13. And oh, did I round anything? No, that's why it gets to be equals. Do you know how big angle R is? No. But whatever it is, its sine is 12/13. Yep, I know. It's amazing. So what would be the cosine of that same angle? How would you get the cosine of angle R? Well, go back to your reminders. What does cosine use?
Adjacent.
Adjacent in hypotenuse. So what's my adjacent value? It's 5. And what's my hypotenuse? 13. And then your tangent of R is going to use which two pieces?
Opposite.
Opposite and adjacent. So your opposite is 12, and your adjacent is 5. So can you get tangents that are bigger than 1? Yeah, all the time. It's totally cool. So now, please attempt to find sine, cosine, and tangent for angle S in this picture. Go.
Oh my, we're doing trigonometry.
Let's go. Sine, cosine, and tangent. What should you do first? Label your reference angle. Then find your sides. So this will be the hypotenuse. This will be your opposite. This will be your adjacent. I would do that before you begin.
Wait, how do you know which one is the theta?
Because I told you the sine of angle S.
Okay.
So S is your reference angle.
Oh dear, I did it wrong. I think you're going on a bit of a tangent here.
Let's see how many uses you get out of that in this unit.
Oh my gosh, like, I was waiting for trigonometry just to make fun.
Okay, so listen. So how does one get the sine of angle S again? Opposite over hypotenuse. So did y'all do 5 over 13? Yay! Oh wait! Look! That was the cosine of angle R.
Yeah.
Since I switched the angle I used, I switched where the ratio was. So the sine of this guy will be the cosine of the other guy. That always happens in the same triangle. The sine of one of the angles will always be the cosine of the other. Kind of fun. So what's the cosine of S? It'll be adjacent over hypotenuse, which is 12 over 13. Look, the sine of one of the angles in the triangle was the same as the cosine of the other angle in the same triangle. Because you're just switching which one's being opposite and which one's being adjacent. So that's kind of a fun little thing you can use to take shortcuts if you want. But the tangent doesn't work that way, sadly. What's the tangent going to be?
5 over 12?
5 over 12. That one is just flipped over from the previous tangent.
I'm confused about theta.
I can't hear you.
I'm confused about theta. How did you find theta?
I just, see how they're asking about the sine of S? That means find the sine of angle S. That means that's the angle I'm referring to, and that's the one we call theta.
The sine will always be referring to.
No, this letter after your trig function will always be referring to an angle, and that angle gets called theta. So you can find the sine of theta, which in this case is S. You can find the cosine of theta, which is S. Or you can find the sine of theta. In this case, theta was R. And so I labeled R as theta. Okay? So whichever one they're asking you to work with is the one that you label and focus on. Okay? So that leads right into our next example. Now we're going to use these things to find the mystery side.
Yes.
See, we're actually going to solve problems using trig. Okay? Now look at this problem. It says label the triangle with respect to the angle. Which angle do you think they're talking about?
65 degrees?
The 65. It's never going to be the 90. The 90 never is the important one. It's always the acute one. And what's the symbol for the acute one we're focused on?
Theta.
That's your theta. Because it said with respect to the angle that we know. Okay? So now that I know theta, What's my hypotenuse? 8. What side is opposite? Mystery side. And adjacent, I don't even have a letter for. So here's what's going to happen then. I want to figure out x. And so I start thinking, okay, I'm going to use trig to do this, because I don't have a special right triangle here. I don't have two sides of the triangle, so I can't use the Pythagorean theorem. But I can use trig. And the way you do it is you say, okay, what angle am I focusing on? 65. And then what are my three trig functions? Sine, cosine, and tangent. Which one of those can I set up based on the stuff that I see in this picture?
Sine.
Go.
Well, let's see. I know the hypotenuse, so am I going to use tangent, do you think?
No.
No. So I need to use one of these.
It's
Now, if I'm trying to find x, that's the opposite. So I have opposite to find. I know hypotenuse. I'm probably going to use sine in order to do it. And so you set up the sine of which angle am I focused on again?
65
The 65-degree angle. And it's always going to be my opposite over my hypotenuse. So what is my opposite side?
X.
X. What's my hypotenuse?
8.
Is 8. You just set up an equation with trigonometry.
Yeah.
Gasp. Oh, but I wanted to find the missing side x. What do I have here? X divided by 8. I don't want x to be divided by 8, but hey, you took algebra. And in algebra, you learned how to get rid of things that were divided. Okay? Dina, how do you get rid of divided things? No, it's already in the denominator. How do I get rid of stuff that's been divided? I multiply it. So I go, okay, I'm going to multiply this side by 8. Up if I did it to the right.
Gotta do it to the left.
Got to do it to the left. So now I know that, oh look, the 8's canceled and I'm left with just x. X equaled 8 times the sine of a 65-degree angle.
I'm confused.
Tell me where I confused you.
How did you do x divided by 8 times 8? And then
Well, I just had x divided by 8, right?
yeah.
And I wanted the x by itself.
Okay.
So I can just know what x equals, true?
Yeah.
So how do I get rid of the divided by 8?
Multiply.
Yeah, that's our multiplication property of equality. So if I do it to the right, I do it to the left.
Yeah.
Okay. The fact that it has the word sine in it doesn't change the rules of math. I'm still just trying to get x by itself. Okay? And so I hope x is by itself. This is your answer. It's an exact answer.
So
See, it has an equal sign and everything. Now, do you wonder what number that is?
Yes.
Now, if you put that in your calculator, is it going to give you something nice and pretty, or is it going to give you something disgusting?
Ugly.
Probably something disgusting. So we're going to be approximating x now. So ask your calculator, what is x approximately equal to when I have 8 times the sine of 65? And you don't even have to type the times. You can just press 8 sine 65, and it'll tell you. I'm sorry, what was that? 7.25?
how many?
So this side was approximately 7.25.
Math.
That's it. All you have to do is get x alone, just like you did in algebra. This is not new or different. Let's look at example 4. What do you start with if you want to do it? You read the problem. Label the triangle with respect to the angle. What is going to be our the angle in this one?
65 degrees.
This 65 degrees. So there's my theta. That's the one we're focused on. Now label your hypotenuse, your opposite, and your adjacent. Takes you 3 seconds, 1 second for each. I always do hypotenuse first. Here's the opposite. Here's the adjacent. That way you don't lose track and you're not accidentally mixing them up in your brain, because brains are goofy. And now you think, okay, what's my reference angle? The 65. So I'm going to be using that one. Which trig function can I use with this 65? Let's see, I'm trying to find x. That's an adjacent. I know I have the hypotenuse. Which trig function uses adjacent and hypotenuse? Cosine. So I know I can do the cosine of my 65-degree angle. And what are the parts for a cosine again? Adjacent, which is x,
Over hypotenuse.
and over my hypotenuse, which is 8. Oh, I don't want x divided by 8. I just want plain x. How do you get rid of the divided by 8 that's hanging out here?
Multiply.
What? You divide to get rid of division? You have to multiply. You have to do the inverse operation. So I have to multiply this up. If I do it to the right,
Gotta do it to the
gotta do it to the left. And those will cancel out. What is 8 divided by 8? Now, what is 8 divided by 8? 1. Oh, what's 1 times the x? See, we got x all by itself. That's why we did that. And then over here, you've got 8 times the cosine of 65. That is your exact answer. But what if I say approximately? What if I ask for the approximate answer? What do you have to do?
calculator.
You have to ask your calculator, what is 8 times the cosine of 65? And what do you get it to be? 3 point, how much? 381, blah, 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 blah. 2 or 3 decimal places is best with trig. You should round it. Did I not, did they not round this? Oh, let's usually do 2 or 3 decimal places. We're never going to use just 1. Okay? So this is your approximate answer. Okay? You guys need to be familiar with both things. Because sometimes I'm going to say, give me the exact answer. This doesn't look like an answer. But if x is by itself, that's exactly what it is. It's this. If I ask you for an approximate answer, you can give me a number, but this is the legit exact answer for how long x is. Oh, x is approximately 3.381 when this is the 65-degree angle. X is approximately 7.25 when this is the 65-degree angle. Did you notice that both triangles were the same except for where the 65-degree angle was? And switching the angle, switch the lengths. Okay? Right. Try setting up and solving number 5. I'll give you a couple minutes. Y'all work together. Yes?
What's the, I think it's
Oh, guys, it's hard to see because it got typed over. This is 11 right here.
that would have been.
You go get candy because you're the one who were first to say, hey, something's goofy here. It's an 11.
I'm a little slow.
That's okay.
You don't have a hypotenuse.
We don't have a hypotenuse? Oh, we don't know what value?
Yeah.
Okay. You scared me for a minute.
So it's x over 11.
Do you round those 3 decimal places or 2?
Go with 3.
What did you get?
Okay, I know I'm going to use the 58-degree angle. Okay, somebody tell me which trig function you picked. Maddie, which trig did you decide on? Tangent? Let's see, so, oh yeah, we don't have a number for my hypotenuse, so I can't use sine or cosine. That just leaves me tangent. So the tangent of 58, so that's going to be opposite over adjacent. So that's x over that mystery 11 I had to tell you. Am I setting up right?
Yes.
Okay, so I need a victim, trin. How do I get rid of that 11? Multiply it on both sides. So now I've got 11 times the tangent of 58. There you go, your side is 11 tangent 58. You got it right. That's your exact answer. Did anybody go ahead and round it and give me the approximate answer? A few people. Alex?
17.604.
17 point, how much?
0.604.
604-ish. And since you rounded that, that's approximately x. Okay. Look at you guys! You're doing trigonometry! And you are not even dying.
It's not a trig.
Okay. Try number 6.
I sign off on that.
Number 6.
Do you want a cosine? Like, what's your sign?
Yeah.
I love this unit.
Number 6. And even better, all of these are going onto YouTube.
Oh, perfect.
Oh, no.
Everybody who watches this lesson is going to... Oh, that's where all of those videos are. When you click the link in Canvas, it takes you to YouTube. You should. Subscribe, like, ring the bell.
Yes.
Actually, this is my favorite class. I love this class.
Okay. Then you have serious mental problems.
I know.
You like math class?
No, it's the easiest class, like AP Human.
Don't say the word.
No, AP Human is the best class.
No, you're lying. There you go. My oldest would agree with you. He loved AP Human.
We have such a good...
Did you study?
Yes.
Honors history is such art.
I know. Well, it's like
This is the best class.
Okay. What's your reference angle?
it's 26.
The 26. And what was your hypotenuse? The 14. A lot of people get confused on this one because the right angle's on top and then the hypotenuse is on bottom and they don't think that's where hypotenuse should be. But it gets to be the hypotenuse. And this is your opposite and this is your adjacent. And so which trig function? I need a volunteer. What did you use? You did cosine? Let's see. Cosine is the ka that uses adjacent and hypotenuse. Oh, look, that's my adjacent. Yep, I can use that. And so cosine of 26 is going to equal x over 14. And then I'm assuming you multiplied both sides by 14 and got that 14 times the cosine of 26 equaled x. Did I do it good? Did I get it right? Okay, and then what? What's the approximate answer going to be? Asking your brilliant calculators.
12.83. No, 12.583.
12.583-ish. And then Mrs. Serta decides y'all are having too much fun. And I give you example 7. Just set it up. Just set it up.
That doesn't look that bad. Famous last words.
No, famous last words are, hey y'all, watch this.
Oh, I get it.
I get it too.
Number 7.
I see. 22 divided by 9.
Oh, that's good. Oh, that's really cursed.
How do we do that?
Wait a minute. But I had my calculator.
How do you divide by x?
That's interesting.
Okay, so
I take it back.
my reference angle is 61. Okay, watch. Okay. Which trig function did you use?
Theta. Wait,
The tangent? Let's see. Tangent goes with opposite and adjacent. I have an opposite, I have an adjacent. Yep, that works. So the opposite is 22. And then why is this one cursed? Okay, shh, because x is on the bottom. When I want x by itself, do I want it to be 1 over x, or do I want just plain x? Okay, so x is on the bottom here, and that's a problem. But that's okay, because x is just a number, right?
Yes.
We just don't know what number it is. So can't I move it around the same way I got rid of the 11? Or the 14?
Yes.
Okay, so how do I get rid of it divided by x?
You multiply.
I multiply by x. And oh, what's x divided by x?
1.
It's just 1. So now, x is no longer on the bottom of the fraction. It's over on the other side of the equation, hanging out. I didn't get rid of the x, I moved it to a better spot. How did I know to do that? Because it literally said divided by x. How do you undo a divided by x?
Multiply.
Oh, you don't yet. Watch. Because look, is x by itself yet?
No.
No, it's times by the tangent of 61. How do I get rid of a times tangent of 61?
Divide by tangent 61.
Divide by the tangent of 61. But if I do it to the left,
You gotta do it to the
we
right.
gotta do it to the right. See, this is all just algebra.
You gotta flip the fraction. Yeah.
But that wouldn't get x off the bottom of the fraction. If you divided off the 22, you would end up with 1 over x. X would still be on the bottom, and you don't want that. Shh. And so now, x equals whatever 22 divided by the tangent of 61 is. There is your exact answer.
Yeah.
Yee! Now, are you curious as to what number that is?
Yes.
Yes.
So you can ask your calculator to approximate it for you. And you probably get something like 12 and change?
12.195.
12.195?
Did you just figure that out in your head? Or
No, I have an answer key. Does it, hey, so let's ask yourself, does it make sense for this side to be 12 and junk?
Yep.
Well, let's think. This angle is 61, so how big would the other one have to be? 29. And remember, bigger side is opposite bigger angle. So 29 is smaller. Is the side 12 smaller than the side 22?
Yeah.
So the answer makes sense.
Yay.
See, you can still check to make sure it's making sense based on all those triangle rules we've had. Okay, last example, and then you get me free to do your homework. But let's try one more of these goofy ones, just to make sure you're not panicking. You already did it? Sneaky. Did you die?
No, we haven't.
It was a good feeling of satisfaction when you do a thing that seemed hard.
I don't know what happened in that.
Well, I don't know if I got it right.
Nope, I don't have a tangent one because I don't have the adjacent side. Can I use cosine? Nope, I don't know my adjacent side. So I must be using sine, which is opposite and hypotenuse. And those are two pieces that I have labeled. So did y'all end up choosing sine, I hope? Sine of what? The 53-degree angle there. And it's going to be, the sign is opposite over there. So you should have started off setting up this equation. And x is on the bottom. We don't want x on the bottom, so how do we kick it out of there? It's already, no! How do I get x off the bottom of a fraction?
Divide by I.
It's already divided. See, this says 11 divided by x.
Multiply by x.
So to undo that dividing, I multiply by x on both sides. And get x times the sine of 53 equals 11. Try really hard. I know that y'all are all very bright. And you start to see patterns and you kind of know what you're going to do before you get started. Still set everything up and work through the steps just to make sure your brain doesn't pull a fast one on you, because it happens all the time as the problems get more complicated. And you don't want to make the silly mistakes just because you refuse to write steps down. Okay? Now, how do I get x by itself?
Divide by.
Now, this is where I divide by the sine 53, so that that'll cancel out, and x will equal 11 over the sine of 53, which is approximately how much? Yes? 13.773, garbage, 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 garbage. Okay? Y'all can do this. I believe in you. So you've got the remainder of the time to now tackle your homework and see how you do.